And we are recording. Welcome to the evening of Python coding. We have Erik van Widenfelt here. I hope I'm pronouncing the name right. I know him for many years, but I could not pronounce it fully. Did I pronounce it right? Erik?
It's okay. Van Widenfelt is how we.
Widenfelt, not Widenfelt. Okay. So, Erik and I met in the evening of Python coding many years ago. And he was always away. Actually, it was in the chat, and he was always away. He said, "I'll be back in Austin. I'll be back in Austin." And we eventually met, and then I figured out why he's always away. He was saving half of Africa. So literally, he was doing clinical trials related to HIV, and today he's doing clinical trials related to other things. And he wrote some interesting software for that, and it's open source, meaning you can download it. And today we have him demo this open source software so people can learn about it. So, Erik, with not much ado, go ahead and show us your clinical EDC, I believe it's called.
Yeah.
Clinic EDC. Yeah.
Okay, great. Thanks, Jacob. Let me just get myself out of the way here and then share my screen. Okay, is that visible, big enough?
Yeah.
Okay, so yeah, thanks. What we're going to look at today is this is our GitHub repo is called Clinic EDC, and we publish everything on here. And there are some other repos that are for specific trials that you can follow links to from here to the other trials that we're working on that use the modules that are in this repo. So what we have are a suite of Python modules, as it says here, that extend Django so that you can build a clinical trial data management system and handle the data collection and the management and the monitoring and the auditing and so on for multi-site randomized longitudinal clinical trials. So let me explain what that is, the longitudinal clinical trials. So clinical trials, I mean, during COVID, we've heard a lot about clinical trials being done to test the efficacy of a vaccine or something like that. What we've done over the years are clinical trials in HIV, looking for ways to improve, people who are infected, their outcomes and their way forward. And we started with trying to look at a vaccine way back in the early 2000s, and that's when I first, interacted with Anthony Fauci, not me talking to him, but he came and did a keynote address. I think it was in 2006. And he just said that as far as a vaccine for HIV, that's not going to happen. We didn't get anywhere with all the trials we did. We had actually done one clinical trial in Botswana for a vaccine, but what was a more, without the vaccine, the next approach is to try to improve people's lives. So most of our trials focused around trying to find the best drugs that we could use and how we could actually roll them out in, countries that don't have a lot of resources and slightly different cultures and different healthcare systems and so on, and different perceptions on, what treatments would be like. And you can't just buy a bunch of drugs and walk into a country and dump them. You got to do some research to figure out how it's going to, how you can actually effectively get medications, treatments, approaches to how you organize clinics. All these things we do through clinical trials and then analyze the data and come up with, and then, publish our findings, and also work with the ministries of health in these different countries to recommend public health policy. So we've been working in South Africa, we've been working in Botswana, we've been working in Tanzania, Uganda, Malawi, and some other countries. And my work in that, because I'm saying we, is mostly to facilitate investigators to be able to take their their ideas and turn it into an operational system that they can collect and manage the information that they're trying to get for the clinical trial, while following all the regulatory rules around running clinical trials. So the big thing around clinical trials is that you're collecting personal information on individuals, and individuals who are at risk. They have, perhaps they're HIV positive and not everybody knows that, or whatever the situation might be. So we have a responsibility that if we're going to collect their data, that we have to keep it secure. And also,
Нет, ты что, съел?
Нет.
Okay, 1 second.
Sorry,
We'll have to figure out
is that a question?
Дожуй и все.
1 second. We need to unmute someone. Here's iPhone. Okay. Yeah, go ahead, Eric.
Okay. Yeah, and also to make sure that some of these scientific proposals can be quite complicated to operationalize. And I tell you, most of these trials fail not because it wasn't a good idea, not because it wasn't a well thought out scientific investigation, but it falls apart when it comes down to getting the data. The deliverable of a clinical trial initially is the data set, and then analysis and publication from there, but it usually fails on getting the data set. And I've seen this over and over throughout trials. And even the work that I've, in the last few years started in Uganda and Tanzania was basically somebody calling me in and saying, we've been doing this for 3 years and we have nothing to show for it. Is there a better way to do it? So that's where we come
I must interject here. What happens after the clinical trials have been, even if Erik is highly successful, there's still a problem with the data. So it's like, this is why whatever Erik is doing is very important. But Erik, you kind of digressed. Can you add, while you continue the story, can you tell 2 things so people understand? First of all, what's randomized and what's longitudinal, so people understand.
Okay, so yeah, sure. Longitudinal means that you're collecting data over time. So what you'll do in a longitudinal clinical trial is you will define time points. Maybe you're going to collect every month, or maybe you're going to collect, something like that. Every month you decide these are the data values we're going to collect. Next month we're going to collect these data values, these biomarkers, and things like that. Some trials are really straightforward. It's just a fixed schedule every month. Other ones are more event driven. If you're dealing with mother and child pairs, if the mother is pregnant, then she's on one schedule until she delivers, then the schedule changes. So it's more event driven, but that's what longitudinal is. You're following over time. And you're monitoring something. For example, if you're trying out, like one of the trials, we're testing metformin, a very common and very cheap drug, but looking to administer it before people get diabetes, not to wait for them to get diabetes. And is there a benefit in that? And so we follow them over. The first trial we did was a phase 2, is just over 1 year. We're now doing the phase 3, which we're doing over 3 years. So we'll be able to see, and we get information from them. In the beginning, it's more frequent, and then as you get well into the end of the first year or so, and you start doing every 3 months or something like that. Randomized means that, so you have, it has more to do with like who knows who's getting what. So first thing to understand is that you could have a blinded trial, and the blinded trial might be that the patient doesn't know whether they're getting active agent, drug, whatever, or inactive. So they might get placebo or active. But if it's double blinded, neither the healthcare worker nor the patient knows who's getting what. And this is obviously to try to make sure that there's no bias in what the patient will report, because they believe they're on the drug, so they might be reporting more favorable, or the physician might think that you are on the drug or you're not on the drug, and then without realizing it, adjust how they record information. So if you eliminate that anybody knows anything about who's getting what, then you can remove at least that type of bias. Bias is the death of all trials. And so
Mhm.
everything you can do to try to remove bias is essential. So when it's randomized, what we do is we'll screen a person for a trial based on some criteria that we need them to meet before they can get into the trial. And then we will randomize them. So we will decide, in fact, our system here decides whether they should go on the placebo arm, for example, or the active arm. And the system that I have here doesn't actually do the randomization because you can't do it on the fly in real time. Well, what I mean is you can't decide right there. It's not just a 50-50 thing all the time. So what we'll do is have a statistician prepare a randomization list, which is basically just a list of slots that I will pick off in order of that list, and they'll be blocked. They have either like what they call block 4 randomization or block 8 randomization, and then they can be stratified by gender, by location, and other factors, depending on how complex the randomization algorithm would be. But for the system here, the way I designed it, it's just to take the next available slot off the system from a table. And then multi-site, you understand. Yeah. So most of these trials are multi-site. So multi-site might be that you have more than one site within a single country, or you might have multiple sites you have multiple sites within a single country, or it might be across multiple countries. Most of what we're doing at the moment are multiple sites in 1 or 2 or 3 countries. Yeah. Okay, so the sort of health domain that I've been working in is HIV, diabetes, hypertension, and also looking at integrating models of care. So HIV in sub-Saharan Africa is very well managed and very well funded, but diabetes and hypertension is not. So for example, I'm in Uganda and they show me the HIV clinic, which has USAID money that keeps it nice, well-funded, nice filing system, a nice place for the patients to sit when they first get there, plenty of staff, lots of drugs, everything like that. And then over here, they've got the, the diabetes, hypertension thing. Watch your step. There's a hole in the floor. We've got no, we've got a book here, but this is our register of patients. But when I look in it, it hasn't been updated for a year, and they don't have, they're struggling to find money for paper, and it's just a complete disparity in funding. So in our trying to bring models of care together, or in looking at different models of care, we want to try to see if we can piggyback the diabetes, hypertension along with the well-funded HIV. So the research would be to see how that works. First of all, you don't want to make the health outcomes for the people who have HIV to go down. You wouldn't want to make it worse by bringing in these other patients. And at the same time, these other patients may not want to hang out or be seen at an HIV clinic because of stigma and things like that. So there's lots of social factors and so on, as well as other factors. And we will just look at the health outcomes to see if we can see a problem.
Erik, Angelos is asking, which company do you work for? So explain.
So right now I work for the Liverpool School of Tropical Medicine, based out of the UK. But
before this, you were working for one of the
Harvard Teaching School of Public Health, and they have an institute in Botswana that I was leading the data management and IT stuff there. Yeah.
And the software that you were using, you started developing then, and you continue developing now, correct? What you're going to show us?
Yes, yeah. So it's got a lot of years of of usage and experience built into it. Yeah. So maybe we can, unless there's some questions, I can move over to the demo.
You can move to the demo. It's like it was important to put people in the context of what it is and how complex the problem. Because from what we understand is that so far is that your software handles many, many elements that will have to work for years, and the data will have to keep integrity for years. And it's very important data, and we don't want to lose it. This is what I got from all of this preface. And now let's show us how you do this.
Okay, so I have put together, I've talked about this stuff before, but I never really like built, made it so you could build a demo. So one of our trials that we're doing is called the META trial. So this is the metformin trial that I referred to, where we're looking at people with pre-diabetes and treating them with metformin. So this META EDC is the actual EDC code that we're using on the trial that's actually operating now. And then I've created this demo, which is basically taking, I think it's the most recent version or the previous version of that, and we can build it on a local machine. So I think we're going to go ahead and do that. I put some links here in the README on the META 3 demo project. I think I don't know if you put that in the. Maybe I can put that in the chat because I don't think it was in the.
If it's in GitHub, then people should have it because they have the link.
Yeah. Okay, so
it's there.
Yeah. So let's get started. So the first thing that you would have to do yourself, which I'm not going to do here, is you just have to have MySQL and Miniconda or some, for the virtual environment. If you're going to follow along with this installed on your machine, which is pretty straightforward. You can get Miniconda there. You can get MySQL from, or even probably MariaDB would work fine as well. So I've given you just here to create. Go ahead and create a database. Next thing would just be to create a project folder and pull the repo into that project folder. So I've just packed the 3 commands together so I can do that. And next would be to build the Conda environment. We're running on Python 3.10. And then I'll activate the Conda environment. I don't know, for those of you who are kind of new to this, we don't install straight onto our machine. We build a virtual environment and then we install things in there so that it doesn't affect the machine in any way. And then when we're done, we can just delete that virtual environment as if you never installed anything. So Conda just asks you one question. You can say yes, and
so far you just installed all the dependencies to be able to run and the library that you need.
Not yet. I'm just building the there's some sort of core dependencies for the environment, but I haven't installed the actual META 3 demo yet, or META system. I'm sorry that it's called META. That was for metformin, not Facebook Meta nonsense or anything like that. But it's not a great abbreviation because it does cause problems sometimes with search and replace. But anyway, so what that did here was, you can see here that the demo has the virtual environment has been activated, so it's running, it's open or running, whatever. And the next step would be to install my software, the EDC, the META EDC, the protocol specific version of it. So let's go ahead and do that. So most of these are EDC modules. I know it goes kind of fast, but you can see. And if that first screen that I was showing you, Clinic EDC, that's where all of those live. And they're all packaged and versioned as we go. The version numbers actually move pretty quickly because I don't really have the resources to anyway, when we make changes, we just maybe once a week even bump the number up of the EDC modules. So yeah. All right, so that's all been installed. If you do a pip freeze and you say grep it for EDC, then you'll see that all these EDC modules make up the system. So some of them will deal with adherence, adverse events. When people get really sick, you are required by funders to report that within 48 hours. Just scheduling an appointment, the informed consent procedure, which you may not be familiar with. But in order to collect data in the context of a clinical trial, you do have to make sure that the patient you are going to collect data from understands what they're getting into, understands that if they want to get out of it, they can just get out of it, they can pull out, and you're not giving them any sort of undue enticement, like money or anything like that to convince them to join. They have to do it at their own, their own decision, their own free will without any enticement. And there's a lot of other things here. You're welcome to look at it. So the next step would be we don't put a lot of the variables or the environment variables or the customization variables in the code base. So we put it in a separate env file, which is sort of, I put a note here that refers you to that 12factor.net, which sort of helps you separate your code from your configuration data and so on, especially when it comes to things like passwords and so on like that. You don't want those to be in any kind of code. And if you accidentally commit something like that to GitHub, you'll get a message pretty fast that you did that. So, okay, I copied a sample environment file, and I've now put it, if you just wanted to take a quick look at that, it's just a bunch of, we run in the cloud on DigitalOcean, but they sort of emulate AWS. So we have, when it's running on the live system, it's working like that. But right now we're just gonna run it on the Django test server. Okay, and the next step would be that we need to get our username and password on the database that we installed earlier, MySQL servers. So we can just do that. I've got some dummy information here, but we just act as root because we need to be able to create tables, and create a nonsense password there. Okay, and
usually don't show those things. Here it's just a demo. It means
it's just
nothing.
nonsense, so it doesn't matter. Yeah, it doesn't matter. I changed it.
We have beginners here. Never show passwords or stuff like this when you demonstrate. Nothing real.
It's not real, but it is a password. Okay, so this next step here is that's pure. This Python manage.py check. This is a pure Django command. I gave you a link right here to it if you're interested in how this sort of, I've got a layer of modules that ride on top of Django. So you start to see some Django stuff at certain points. You can follow in the Django documentation, which is probably some of the best documentation around for these types of projects. And we're going to run check right now. And since we haven't created a database yet, we're not. What it's going to do first is it's going to create some encryption keys because we encrypt all personally identifiable information and any other free text that may, on the offhand, contain some personally identifiable information, and that's a requirement for clinical trial systems. So we'll just run that, and it'll automatically, you can see here, it's creating some encryption keys, which are just RSA keys and so on. And then we get this message, which says that if you want to run things again, you're going to have to flip this settings attribute from true to false. So we'll just go ahead and do that and set this one false. And now if I run check again, I'm not going to see this red message anymore, which is good. I've got these 3 warnings here, but since we're running this on a local machine as the demo, it doesn't matter. So the next step is a Django step. So here, say we have a set of migrations, which is the migrations in Django speak is just going to build the tables in the database, so the data tables, and it's a, I don't know if you're, it tries, these migrations try to keep your code in line with the structure of your table. So if you change your code, then it will generate scripts to update your data tables to match your code. So it makes things a lot easier. So instead of doing that, because that for this trial, because it's been running for a while and there's been a lot of modifications over time, we're just going to restore a demo database that I included in this demo. There's a folder called demo data, and you can get it from there. And this is just the commands to restore it, to decompress it and restore it. Okay, and then the next step would be that we're going to run migration, because I have some scripts that run after the tables are ready to populate some static data and to check permissions that are referred to throughout the system that are stored in the database, and a few other things. So we'll just run a migration here. Now there it says no migration to apply. It's referring to schema migrations, but now it's just doing some post scripts that it's running.
Eric, are you sanitizing the data as you feed it?
So I'll show you when we open up the system. Yes, we do real-time validation as the data goes in, either going to be validation on the actual, just the field value itself, or relative to other field values on a particular form that you're filling in, or relative to other data that you have previously submitted. However complex you want to get, we validate it like that.
Thank you.
So we generate schedules for the clinics, but we want to make sure we don't hit holidays. So we import some holidays that are different, obviously, for every country. And then lastly, we'll create a user that we can use.
Wait a second. You're telling me you now have a database of holidays per country that you're going to use specifically for clinical trial for a specific country?
Yeah, if I'm operating in Tanzania, and I'm creating a schedule in advance as far as I can. So if I don't have any anything that changes the schedule, I know the schedule from the time they join the trial, and that might extend out 3 years. I can create all the appointments now. So I do that.
Nice. Yeah. So this is one of the small little things that you have to do to get, and you have many of those small little things throughout the program, I understand. Holidays is only one of them. You said validation is another. You have many
lots of stuff. Yeah. So the thing about the appointments is you have another thing that kills clinical trials is what you call longitudinal trials. So longitudinal trials, you'll have, like monthly visits or whatever. And what kills these trials is what you call visit drift. So somebody comes a little bit late to their second appointment, and then the staff then schedule, let's say they come late to the 2-month appointment and the next appointment is at 3 months, but they came late. So they came like they came like a week late. Then the staff will schedule the next appointment 1 month later. So now they're scheduling it late for the 3-month, and then they come late for that new appointment. And this continues. And before you know it, by the time you get to 5 or 6 months, they're already 1 or 1.5 months further along than they're supposed to be. And that messes up when you try to analyze all these individuals against each other. They're all coming in at different times. And so like 0 to 6 months for one person is 0 to 8 months for another person. And this is a disaster. So by generating these appointments up front and being really strict through the whole system as you enter dates. Everything's about dates at some point, where you have to make sure that dates make sense relative to each other, and you keep people on their original visit schedule, their original longitudinal schedule. It's very important. So create what they call Django. This is again another Django command. This create super user, and I'll just create full type right. And yes. Okay, and I think so. This in Django is their little test server that you can run on your local machine. Obviously never for production. In production, we run, Unicorn and Nginx, but here we just use run server. So we can do that. And then I can go to, what did I say? Localhost 8000. And I get to it says test server, but this is just a screen. And now the next thing I'd say in the demo is that you've got to change, you can't be a super user, because it kind of messes around with the permissions that we have for the system. But so what I'll do is I'll go to my user account.
What types of users you have?
So we have clinicians, nurses, pharmacists, auditors, yeah, like that. Yeah.
And each one of those sees a different part of the data or in a different way, correct?
Yes. So the key important thing is, first of all, that everybody has to have their own account and somehow make sure that they only use their account and they don't share accounts. I also restrict people to the site that they're employed at. So I don't want them to be inadvertently logging into another site and entering data or registering somebody at the wrong site without, by accident, which has happened in the past. And also, we'll see it right here, we define roles for these people so that they so I'll undo that, and then I'll make sure that these are different sites. So it doesn't really matter now because we're not live, but I'll just choose all the sites as if I'm working everywhere. And then here these are roles, which I'm an account manager, so I can manipulate, I can change other people's permissions and things like that. Let's say I'm a clinician super, which gives me the ability to delete data, but this other clinician can create and update and so on, but not delete anything. And a bunch of other roles here, pharmacists and people who are allowed to request that you unblind a patient if it's like I described in the beginning about randomization. If it's double blinded but somebody's very sick, it is going to be need to expose or reveal are they on the placebo, are they on the active, and this would be someone who would be able to do that. Pharmacists, whether they can prescribe, whether they can see the original randomization list because maybe they have to prepare the drug, and so on. People who are allowed to export data.
Erik, do you deploy biosensors for nanomedical informatics?
No. The only sort of equipment that we've ever interfaced with would be analytical equipment in laboratories like CD4 counters and hematology machines, chemistry machines, viral load machines, and things like that. Not any devices that we would put on individuals. No.
Do you foresee that to help? You're talking about, if you don't collect the data at the proper time for the test model, and it seemed like if you had a wireless transmission of the necessary bioinformatics from those involved in the trial, it would help immensely.
Well, I think in the places that we're operating, those kind of devices. Yeah, I'm not sure how. I mean, obviously, you're right. If you have a device that you can interface with, even if it's a blood pressure device that you can use in a clinic and you can get immediate information from it without having somebody have to transcribe it, that would be great. But I think the interfacing that I found more urgent to do would be like laboratory values, because if you send out a blood sample and you're doing a hematology panel, for example, there's 28 variables and they're all, float values coming through, and they're so prone to transcription error that it's almost impossible. And there's not much you can do. You can't validate it. You can say whether it's abnormal or not, but you don't know if you're getting the right values in. So by interfacing with those types of things, that's a real benefit to healthcare in general. And here we take it for granted, but in some of the other countries, it's coming along very well for a lot of places. But that's where the real value is. I don't think we're at the stage yet where, well, I'm always open to ideas about devices and things like that. Yeah.
I foresee the World Toilet Day, because that's where can we get some samples? And that's where I see biosensors and to wirelessly transmit to secure the data.
Yeah.
David, this is wishful thinking. There's many more things that need to be done there.
The Brits are about World Toilet Day, and you go on we need some samples, and there you go.
Yeah. The thing is, we're not there yet. Let Eric continue showing what he has. But yes, you're right.
Thank you.
So if you've built anything with Django, this looks probably somewhat familiar. I've just manipulated the template and some of the theming a little bit, but it's pretty much still a Django form.
So this is a form that the person fills in, and who decides the questions?
So the questions are the science, right? So that we've decided how. So a lot of times, anyway, the sort of the stages in getting to the point where you're actually looking at a form and starting to collect data. First thing is you want to get your funding, so you write out your scientific idea with everything that's required, and then the next stage is to take that idea and put it into we just call a protocol document, where it's your reference material for any question you might have for the next stage, which is you're trying to operationalize. So what you're looking at here is a screening form. So this form is looking at the inclusion and exclusion criteria for people that potentially could be enrolled to the trial, but they have to meet these criteria. And this is where, myself and others will rewrite a lot of these questions and break them down in such a way that works best for wherever we're trying to administer it, and to make sure that we don't let anybody on the trial who's not supposed to be on the trial. We definitely don't want that.
Yeah. So, but you actually can edit those questions, correct?
Yeah. So if you take a question like number 2 here, and if it's screening consent. So if I go to my code here and I look at in the meta trial here, and I have a model and screening consent, and I think this is in part 1. So there it is. Has the subject given his or her verbal consent to be screened for the trial?
And you can change this text if you need to.
I can change this text. You see, the power of doing data management for clinical trials in this way is that they have, if you read some of these FDA guidelines and guidelines coming out of the whatever these the international harmonization, is it ICH? So what they talk about is is risk management. They say, look, let's get beyond just trying to make sure we get completeness of data. Let's talk about risk. So risk means that you would look at the data at the trial as it's moving along, and as you're monitoring it, and start to see a trend or a problem or something that you didn't design very well, and you will fix it and change it and put in protections so that that problem cannot be a problem for the future. And since it's so easy to make changes and cut another release and make changes and cut another release, we just are able to minimize risk throughout the course of the trial. And that being risk of problems with the data. But it's not just based on what you knew when you first started, which is more like software, right? You're only so aware of your problems in the beginning, but as you start, your users start using the software, as you start looking at the data, as you try to build reports around the data that you've collected, and some, and so on, you start to realize that you need to change certain things here and things there. So yeah. So, so we build validation in. So if I try, for example, to just save this form now, I'm going to get some, this field is required, obviously. So let's say I purposely select, so have they given their verbal consent? If I say no, it's still going to, in these very first questions, it's just going to stop you and say, look, let's not go any further because the person is not allowing you to do this. But obviously that's a ridiculous question in some ways. We wanted to make sure that they were not enrolled in the previous trials. So we want to say no. If we say yes, we're going to get, it's going to accept it because we want to know everybody that we screened. We want to have that data so that we can describe the population that we screened. And then the next step will be the population that we enrolled. But if somebody says, yes, they were enrolled, then in the previous trial for this question, they're not going to be allowed to continue, but we'll say no. I'll just put in a dummy identifier here. I'll put in some initials. Let's say male. Let's say I'm 20 years old. So I'm HIV positive. Am I on treatment? Am I stable on treatment? Do I have a viral load that is less than 1,000 copies per mil in the last 12 months? So we had a problem that this originally said the last 6 months, but because of COVID and because of how well these HIV drugs work, a lot of the countries are not doing viral loads every 6 months anymore. They're only doing them every year, if even that. So we had to extend that. Are they going to stick around where the study is? It's not applicable. If I say yes to pregnancy, then it's going to inform that person that you can't do that because this is a man. And then we will go to the next stage, and then that will save. So far, some of these values that we still need are pending, but we'll get them in part 2. And I'll fill in part 2, and that will. I don't know if you want me to go through all this, but I can go through them really fast.
No, just jump.
Yeah, so the only way I can get any further is, what's that?
There are many questions that you have to enter for each person you're entering.
Yeah, so let's say yes. Second stage of the screening, yes. Yes, I don't know. Whatever, we'll see I'm not sure what it's going to do. Not applicable. Okay, anyway, let's not go through the whole thing. What it'll do is eventually then get to the point where we have somebody on a trial. And I think what I can do is just log into a test server here. I can remember my password. Probably. Oh, good. Okay. So this is just a test server that we have the sites work on when we make changes. And once we finish screening somebody, then it's going to be something like this. We went all through like number 7 here. We went through all 3 parts of screening, and then it offers them the consent, or it might say they're not eligible. So a big part of a trial is to determine that eligibility. It's very complex. You saw all those questions. If you were to do that manually, it's almost impossible to get it right. And most of the sort of human resources are going to be piling around trying to make sure that, you know, simple criteria are met and people aren't being enrolled who shouldn't be enrolled. And what'll happen is that you probably won't be able to realize till a month or 2 later that you got somebody on trial that wasn't supposed to be on trial, and so on. So by doing it this way, we never have that problem. Next step would be to consent. This is kind of what a consent form looks like. Just give it a second. Do not know why that's taken a while. Anyway, and this asks for personally identifiable information. Everything is encrypted. And once that consent's finished, then it'll shoot us over to a dashboard. And this is where I've generated all the longitudinal appointments looking forward. And then a longitudinal appointment will have data that we're going to collect. So here are all the documents that have to be filled in. Do a physical exam, patient history, get their ARV regimens for people with HIV. We look at insulin, renal function, liver function, full blood count, lipids, malaria tests, and so on. And we also, if we're drawing blood, we order the blood, and then we are able to track and calculate a turnaround time so that we can make sure that data gets brought in a reasonable period of time. And there's a lot of other things going on here, but that's kind of the system. I don't know if there's any questions.
You showed this to us in action, and you showed us how to install it. So
Yeah.
if you want to modify it, let's say you're running a new clinical trial, and how do you modify things?
Well, so we have some other trials, right? So let me just go back to this. So what I said in the Clinic EDC thing here is that, you know, you sort of, if you can, all these, where is it? Sorry, here, read more. All these, like this trial just opened last week. We just got it running. So how we usually just build a shell of the different sort of protocol specific modules. So there'll be an EDC AE, and then we put on top of that something that's protocol specific for anything that, so that it works for that protocol. And we do that for a group of these modules here. So the general structure is that you screen, and then you have longitudinal data you collect. You might have some static data in lists. You're going to have laboratories. We have obviously what you saw was a dashboard. We have the consent process and maybe some specifics around permissions. We have adverse events, and then we have the visit schedule. And this is the same for every trial. If you look at this one, or you look at the one that the demo is based on, you're going to see the same thing. You'll see that same sort of structure. So we start with an empty with a shell like that, and then the main work will be in building the models, which is a very Django-ish way of you build these model files for each of the forms. So we do one model, one form, one table. That's how we work to make it simple for analysis. Yeah.
And you support MySQL currently as your database, correct?
MySQL or MariaDB, haven't really thought about using like Postgres or something like that, but that would probably be a good thing to do as well to support that. There's really no reason not to. I think the only reason that had a problem with Postgres is because of the encryption. I had a problem with the binary field, but that was, some time ago, and I haven't gone back to look at it. Otherwise, everything else is compatible because it's Django there's a layer that Django is abstracting the database pretty much. Yeah.
Ara is asking who's entering the data. If it's the medical personnel, how long does it take to train them to use the system?
Yeah, so it is the medical personnel that are entering the data. And the nice thing is that we'll go from, so initially, person has not ever used the system before for any trials, which sort of suggests that they might not even have done a clinical trial before. It'll take a little bit extra time, but we really only might have like 2 sessions that we go through it. That's it. And for people who have already used it for a previous trial, we really don't really need to do anything except to highlight some differences, mostly around the validation of the data, so that they understand some of the responses that will come back. But that's more about teaching them about the protocol and less about teaching them about the system, because it's pretty simple and straightforward. So if we have people that have already used it for one trial, they really don't need training for the next trial.
Okay.
But what I do find essential in operating this is I do want to have somebody on the ground who is my internal auditor. And I don't need that person to necessarily be technical, but I do want that person to be a very meticulous and detail-oriented person who's willing to look at every little aspect about the data, take out lab results and compare them and see, and look at the visit schedule that was generated and say, hey, wait a minute, this is not what I expected. If I can find somebody like that, and I have somebody like that in Tanzania, he's absolutely fabulous. And he comes back with all kinds of stuff, suggestions and so on. And it really helps improve things to have that person who looks at every patient and looks at everything that was collected and really looks at it in detail, and then comes back with constructive information on what needs to be fixed or what might be better. Users have talked to him and said, hey, can you do this? Can you change this?
Have you tried anomaly detections in a machine learner?
I don't think there's enough data for that to use machine learning. Don't you? I would assume you need more. You know,
David,
you're
David,
dealing with like at the most
You-
like 3,000 to 5,000 people. So, and it's maybe like 250 variables per time point or something like that. But the time points are not. There's like might be 12 time points. There might be 24.
you need more data.
Yeah.
You're suggesting you need much more data for that, for anomaly detection to be worthwhile for a network to be deployed.
Yeah, so I mean, anomaly detection might be that the statistician trying to generate, starts working with the data, and if you have a good statistician, they'll start to pick up outliers and things like that, and question them, and try to get either a clinical explanation: is this a valid value, or am I looking at a mistake of some sort? Yeah, but we do put in, all I can do in sort of data entry validation is I can do logical checks to make sure that things make sense logically, or I can put in boundary checks, or and with laboratory values, what we do is we call grade them. If it's very severe, it would be a grade 4 or a grade 3, grade 2, grade 1. And the NIH has laid out, for particular laboratory values, like your white blood cell count, you'll have ranges. And if they're in that grade 4 area, you need immediate medical attention. So that is also there. So if somebody makes a mistake and puts an absurd value, it's suddenly going to come up with all kinds of reporting requirements and things like that. And they'll quickly realize that, no, that's not what I wanted to do. Yeah. So I see something from Randy, medical.
Yeah, they're asking about HIPAA, MFA encryption because
so we are using encryption. So the encryption is a module that I wrote some time ago, which does field level encryption. So that has turned out to be sufficient for our purposes. plus, the servers that are running out in the cloud are, I think I follow enough to make sure that they are secure. The Harvard group, their IT security, whatever people, I remember they sort of dragged me through it for like 2 or 3 months to try to make sure that, this met their standards, and I got through it. So, but I don't know if that compliance, like HIPAA compliance, I think there's probably some organization you have to get a certificate from or something like that. But in terms of FDA regulations, they've gotten a little bit better, but they're not regulations, they're guidelines, right? And they used to be really simple, like 4 sentences. Now they've become a bit more, there's a bit more to them. The Europeans actually have more, more guidelines that are of more interest than on the US side. So I try to follow both. Yeah. I put some links on the demo to the FDA regulations and the ICH stuff, I think.
So let's go back to the beginning. Now people have seen some of the whatever it's doing, understand why we're doing this. At least hopefully they understand some degree. And this goes to, if you now know a clinician is about to do a clinical trial and they are worried about ways to write this, they want to manage it and they want to use this tool. Is this demo enough, or do they need more courses, or how are you going to support this beyond what you just showed us?
Okay, so it's not a shrink wrap package, okay? And these, like I say, it's a suite of modules that you use to build an EDC. So it's sort of like 80% done, but you've got to do the other 20%. And that would be to build the your forms or your models, and then come up with your validation scheme. And the way I do that is I sort of, we're informed from, I have in each, so, okay. So for example, form validation, I've got a module here. And in this module, I've got a README that sort of explains how I expect you to use it and what you can do, and then how I expect you to test it. And then you might look at this and read this, and then I also recommend in here that you look at other trials that we've done. The more recent, the better. So then you might go to the EFFECT trial, and you might take a look, and you'll go to their, this one has actually separated it out, unfortunately, so maybe it's not a great example, but they have their form validators in here. And in here, we've built, if we look at something like, I don't know, this one. So you might look through some of these. Of course, we're doing a lot of, subclassing and things like that, but you might look through some of these and figure out how, how you're going to do it.
So you have to, even if you have all those sets of models to help you, there's still a lot of work to do. It's like the 80-20% you're talking about. Am I correct?
Yes, absolutely. These trials are, when I first started doing this work, most of the investigators kind of looked at me and said, no, every trial is different. There's no way you can generalize. But I'm able to generalize, I don't know if 80-20 is exactly it, but in my opinion, the 80% of it's generalized. It's just the 20% that you have to make protocol or study specific.
Interesting. We have another question.
And sorry, Jacob, the other thing is that as any programmer probably finds out, when you start to program a problem, you know more about the problem than the people who ask you to program it about, right? Because you're getting such in-depth, you're getting so in-depth into it. So, even if you don't have clinical trial experience, you're going to start asking questions like, wait a minute, this and this and this put together don't make sense, because when I try to program it, you'll see. And so the conversation. So even though they have what they thought to be a finished operational manual, you'll still kind of start to tear it apart when you program it. Yeah.
Well, this
I mean,
means this is
I
a
can
good
give you a
process.
very quick example from just this morning, right? So this morning I was looking at maybe I can just quickly pull this up. Since nobody's talking, I'll just
No, there is a question from Randy, or at least a comment.
Yeah. So yeah, go ahead.
So
So
while
just
you're
quickly,
looking for what to show, so Randy said we have a lot of issues with cybersecurity, insurance requiring multi-factor authentication. So I assume that you have also MFA built in.
have issues. Sorry, where's Randy's question? Oh, we have a lot of issues with
chat.
cybersecurity, insurance requiring MFA. What's MFA? Sorry, I don't know.
Multi-factor authentication. It's when you actually put your password, and then you get a text on the phone to write another. Tell us what the text said. What's the code? Anyway,
Yeah.
so you have an administrative, but you're gonna improve it little by little. I assume at some point you might want to include the MFA. It's an idea. I'm just saying.
What is MFA again? I'm sorry.
Multi-factor authentication. It's when you actually
multi-factor authentication. Sorry, I didn't understand what you said. I thought you said move.
Yeah. Apologies.
Oh. Yeah, I mean, I haven't built that in. What I do use is I use Defender, which if I make 3 attempts at a password, then it suddenly will make you wait like 20 minutes for the next one, and to try to make sure that someone isn't just crashing into it. But we have a small, tight group. We're not dealing with thousands of users. That's the other huge advantage we have, is that we have a lot of control over our users. So the security in that sense is not really to make sure that the person who's on it is authenticated, because we're going to get into problems with, I don't have a cell phone, and in some of these African countries, people are swapping out their cell phone numbers, all the time. They're sitting there with 3 cell phones because they're trying to game the best carrier with the best rate, because this carrier had a special this month, so they switch over, and then that one's having a special and they switch over. So the cell phone numbers are moving around all the time. It's not like here where you get locked into a contract and you can't do anything.
Some people, I don't know. Freakers.
What's that?
The term was for the phone. It was a phone hack as a freaker, and in poor neighborhoods, that's the common line at the bus stop. Can I borrow your phone? And you really, yes. And I don't know if that's tribal psychology or people are funny. And it's hard to figure out how to secure and validate data and clean it, and it's a process.
Yeah.
Is there anything else you want to show us, Eric, or are there more questions to you?
I think I've kind of showed, there's not that much to show. If you're interested in, I think if you looked at some of the code, you would see how we sort of extend off of Django, which I think is a great platform to build on. And we try to make sure that we're trying to look to have high test coverage, and so some of our testing and just all the same stuff everybody else is doing, I think. Proper versioning and whatever else.
Randy has something about MFA. In theory, basic multi-factor authentication should be easy to add. When someone logs on, you will generate a random number and text them to the cell number you had on on file and it matches, you let them in. If not, you don't. It's an issue in the US with HIPAA, but may not be an issue anywhere else. So Randy's saying that it's like US regulations may be stronger for some cases, from some environments, which makes sense. But Eric told you this is something that, like, this software is being used in multiple countries that don't have it. But Randy, if you want to add something to the software, I noticed it's GPL license, meaning it's free, kind of. You just have to talk to Eric, fork it, and add whatever you want there. If this was where you were heading, you want some new features.
Yeah.
Anyone has any more questions or comments to Eric?
Thank you, Eric. When you were talking about the swap meet in Africa for the cell phones for the best rates, it made me think of the movie from the 80s called The Gods Must Be Crazy. I don't know if you've seen it, but it is when a new technology comes to a tribal culture, it's a culture shock, and it's in. It's interesting.
I think if you had some of the deals that, the way they do it in some of these African countries, you might be swapping your cell phone out for a different one as well. The SIM cards, not the cell phone, because those are, but cell phone coverage in most of the African countries is excellent, and not that expensive. So I can see where there's temptation to try to take advantage of those devices to do things, but I'm doing things with technology here, but I'm not a real fan of using technology for the sake of technology. And I was in Rwanda once, and they were trying to transmit CD4 results over cell phones, and they were able to do it, right? They were able to transmit the result. But what I did was I said, well, hold on a second, who put the result into the cell phone network that you just transferred across? And then they took me to a room where there was this young girl who had just graduated from high school, and she had a huge stack of papers, and she was just typing them into an Excel spreadsheet with no validation. So it was basically garbage in, garbage out, but very effectively transmitted. Yeah. So, you got to look at these things holistically. The technology can definitely be there. And we did a study in Botswana where we looked at using cell phones to transmit, or using cellular data to transmit results. And we had these little SMS printers. I think they use them at pizzerias or something like that. And so we used a Canal server, and we transmitted the data onto the cell phone network and got to that little printer in different places of the country, and then it would print out a little slip, and then people would lose the slip because it was so small. And so, we got the data there, and we actually got really high quality data there, but it didn't make it to the patient chart, and therefore it didn't make it to the patient, and they still had problems with. And what we realized was that the problem really wasn't about getting the result to the clinic. The problem was that when it got to the clinic, they didn't organize it properly, so it didn't get to from the to the patient, and that was the problem.
You also had, when you started doing this, you didn't have any. Now you're telling about excellent cell phone power, but at the start, I recall you had the talk where there was no communication at all. And you had
so that was cellular data. The cell phone coverage is really good, but when we went out in Botswana, we went out into 30 villages in remote areas, and we couldn't get data pipes out there. So using a lot of times the cell phone, it was, first of all, it was just a little bit too expensive to use cellular data, but it would drop down to 2G, and so there's not much you can do. And even if it's at 3G, it's definitely not reliable enough to do anything in real time. You might be able to use it to like SSH into something and do something and come back out, but not to do anything in real time. What we ended up doing, though, we couldn't even rely on the cell networks at that time. Now I don't think it's a problem, but at that time, that was like 5 years ago. We actually built out with our own towers. We had a lot of CDC money, so we built out towers so that we could at least make connections to villages. And we would SSH at night into a local server that we set up in the village and pull the data, and have data that we collected out in these remote villages would be. We were working with Harvard then. It would be in Boston that very night or the next day for them to look at. So they were able to monitor these remote villages from Boston successfully.
Yeah. Well, you have a lot of stories about things that can go wrong and how you fix them. So I guess we can go on telling stories for more, but I see people starting asking questions on the chat that are not related to the demo. But they do thank you for the demo multiple times. So
Thank you, everyone.
Yeah, so maybe it's a good time, guys. Please unmute yourself or make some noise or make some gestures or something, or write something on the chat. And I want to thank Erik. Erik, thank you very much.
Thank you, Erik.
Thank you.
Don't go away. Don't go away. Some of you were going to say.
Thank you, Erik.
The record.